Continuing education knows that at the end of the day, students want to graduate, and we can help them do that because we really listen to their needs, and we can offer them flexible options both within continuing education and across the campus.
We don't take a cookie cutter approach. We realize each student comes with their own story. So whether it's a part-time student looking to complete a degree program or someone just looking for online courses, we're there to connect them to the resources of the university.
Welcome to the 70th Annual Conference on World Affairs. We have an exciting panel today on the climate path forward, science and innovation. It's Tuesday, April 4th, 2026, and again, welcome. My name is Dennis Ojima. I'm the acting director of the Natural Resource Ecology Laboratory at Colorado State University, as well as an emeritus professor there. We're really here to really hear an exciting state of the science and innovations. But before I get into that, let me just read the University of Boulder's land acknowledgement. The University of Boulder, Colorado's flagship university, honors and recognizes the many contributions of Indigenous people in our state. CU Boulder acknowledges that it is located on traditional lands and territories of ancestral homelands of the Cheyenne, Arapaho, and Ute, and many other Native American nations. Their forced removal from these territories has caused devastating and lasting impacts. While the University of Colorado can never undo or rectify the devastation wrought on Indigenous peoples, we commit to improving and enhancing engagement with Indigenous peoples and issues locally and globally. We do this by recognizing and amplifying the voices of Indigenous CU Boulder students, staff, and faculty and their work. We educate and conduct research supporting student success in integrating Indigenous knowledge into their curriculum. We also consult, engage, and work collaboratively with tribal nations to enhance our ability to provide access, culturally sensitive support, and to recruit, retain, and graduate Native American students in a climate that is inclusive and respectful. So again, thank you for attending the conference on world affairs in this panel on climate science innovation. And add a note, we ask that our attendees remain respectful throughout the discussions. I know you all will, and refrain from undue interruptions. There's no use of signs, banners, noisemakers. You can applaud every once in a while. Will result, if you, violate these rules, you will be asked to leave the room. Time is allotted for questions from you, and we'll be taking handwritten questions from you. We have two producers here that will be handing out little slips of paper and pencils if you raise your hand, if you have a question, and then we'll try to incorporate those questions in the panel discussion that follows. And so now I'd like to ask the panelists to introduce themselves, and I'll start with Lisa and go on down.
Super. Thank you so much. I'm so happy to be here today. My name is Lisa Dilling. I'm an Associate Chief Scientist at the Environmental Defense Fund, which is a global environmental nonprofit. Before that, I worked here at University of Colorado Boulder for 15 years as a professor in the Environmental Studies Department. I've also spent time working at NCAR, if you know, National Center Atmospheric Research up the hill, and also have worked at NOAA. So I have had a long career in all things climate, and I'm just very happy to be here today. Thanks.
Okay, well, thanks. It's great to be here at CWA and to be part of this panel here today. My name is Michael Mann. I am a professor at the University of Pennsylvania. I guess my title is the Presidential Distinguished Professor of Earth and Environmental Science at the University of Pennsylvania, and I have a joint appointment in the Annenberg School for Communication, where I direct a center, the Penn Center for Science, Sustainability, and the Media, and I guess that gives you some sense about my broader interests. Thank you.
Paul Bierman, the University of Vermont. I'm a professor in the Rubenstein School of the Environment and Natural Resources. My background is geoscience, and I've had a long-term research interest in how humans and the environment interact, and I guess a shorter-term interest in science communication, science policy, and speaking up as a scientist. And I love to tell stories, so you're probably going to hear some stories from me today.
I'm Nalini Nadkarni. I study trees. I'm a forest ecologist. I'm in the biology department at the University of Utah. I'm also a National Geographic Explorer at Large, which is my favorite job. And I'm a senior fellow in residence at the Sorensen Impact Institute at the University of Utah. I study forest canopy biota in the treetops of tropical and temperate rainforests, and also the effects of disturbance, human and natural disturbances on ecological systems. And I am deeply interested in public engagement with science, and I work with non-traditional public groups, faith-based groups, artists, and people who are incarcerated, and just about anybody who wants to hear about trees.
So as you see and you hear, we have a very distinguished panel. And as we think about the climate path forward, we've asked our panelists to kind of reflect on 3 to 5 minutes or 5 minutes on sort of what the state of climate science is, including where the uncertainties remain in the impacts and timelines, and sort of how does that play into what technologies that we use to look at solving the science challenge. So each of them have sort of prepared some thoughts, and maybe I'll turn to Lisa first.
Super. Yeah, thanks for that. I'll be quick here just to kind of set the stage, and I might deviate a little bit from those exact topics, but I want to start off with reasons for optimism. I think sometimes these panels or things about climate change can be quite grim and a little bit depressing, and that's real, that's true. However, I do think there's signs of hope, and I want to lead off with that. When I was a professor here teaching here around 2009, 2010 timeframe, I used to teach a class in environmental studies, a big intro class, 400 students. It was like the kickoff to our major, and a lot of non-majors took it as well. And we had a unit about energy. That was one of our units. And we used to talk about the options for decarbonizing the energy system, or what could we do to move away from fossil fuels, with respect to thinking about climate change. And at that time, I would talk about, the different options we knew about and so forth. And I'd talk about something like solar, and I'd say, yeah, solar, it sounds great, but it's so expensive. No one's ever going to be able to use it at scale. It's just really too expensive. This was in 2010, okay? It's now 2026, 16 years later. Solar is one of the cheapest forms, the cheapest form of energy out there. Wind is also cheap. Things like battery storage that used to have the same story, oh, it's so expensive, battery storage, now becoming cheaper and cheaper by the month, by the year. So I just want to tell you that things can change quite rapidly in this realm. And I think, and now if you look at generation, what kinds of generation are being built, the vast majority of what's being added to the grid right now are wind and solar. So, just to give you a little bit of a sense that we can do this, we can change our trajectory, and it can happen pretty quickly. That said, I want to also just quickly say we have some decades ahead of us to get to where we're going. The climate change challenge is real. Climate science, as Dennis laid out, is good. We have good science. There are some uncertainties, but we know very well greenhouse gases are causing warming of the atmosphere. They're having all kinds of impacts on water, on our ecosystems. I think Mike, and Paul probably go into that, and Nalini. So this is a real challenge. We need to be thinking about this, though, as something we keep going on. Like, you know, when you're running a race and there's like the sprint and there's the marathon, this is like a marathon. This is a marathon. We have to think about how long it took for us to get into this pickle that we're in, and that this is going to take some time. And we need to all be digging in as people, actually, into how we overcome these challenges that we have. Technology, as I mentioned with the solar panels, it's coming down in price. It's becoming more affordable. I just bought my first EV last fall. I'm kind of a late adopter, I guess, in this town. It's fun to drive. It's amazing. It's really fun to drive. I think we need to look for that kind of way to get through this transition, to where we look for affordability and what is attractive for people to go through this transition. And I'm speaking, of course, of decarbonizing the energy system. So this is something where we need to be keeping our eyes on the ball, because this is going to take a while. There's going to be bumps in the road, as we're experiencing a bit in our country today. But we need to keep going on this. You can't give up. You got to keep going. You got to kind of know this is a long haul, but we're going to get there. So I think I'll leave it there and pass it off to Michael.
Thanks, Lisa. Actually, I'm going to touch on some of those same themes, so this was sort of a perfect segue. And so some of you may know sort of my origin story. Back in the late 1990s, my co-authors and I published the now iconic hockey stick study, the hockey stick curve. And it became this very potent symbol in the climate change debate. And it was a threat to some powerful vested interests, the fossil fuel industry, because it told a very stark, it was a stark picture, you know, that there's this abrupt warming of the planet that's taken place during the Industrial Revolution. The planet is warming up. We're responsible for it. It's unprecedented as far back as we were able to go 1,000 years. And again, that was sort of a threat for powerful vested interests who are profit from our continued reliance on fossil fuels. And they used their fairly the influence and wealth that the fossil fuel industry has was used to sort of discredit climate science and to specifically to attack my co-authors and me. It sort of thrust me into the limelight, if you will, the center of the center of this very fractious societal debate when I was still just a postdoctoral researcher. And I was attacked, and there were efforts to discredit me and my science, but I sort of leaned into that. It was sort of not not within my constitution to just sort of, give up. I doubled down, and I realized it wasn't just about defending our research, it was about defending the science of climate change against vested interests who find that science inconvenient and have done their best to shield the public from what the science actually has to say. And so I continued to go down that road. I've embraced the opportunity that gave me, those early attacks sort of gave me a platform to inform the societal conversation about what is arguably the greatest threat that we face as a civilization. I feel privileged to be in a position to do that. Today, ironically, it isn't really the attacks on the science that are the threat. Sure, there is a rearguard effort to discredit the science of climate change, but we can all we're witnessing here in Colorado. You are witnessing in real time the profound consequences of climate change. People get it. It's very difficult to deny it, and so the bad actors that we're talking about have moved on. They're not really focused on discrediting the science, but they have turned to a whole variety of tactics, if not denial, deflection, deflection, division, and doom mongering, despair mongering. Ironically, the greatest threat today isn't outright denial of the science or the reality of climate change. It's the denial that we can do anything about it. And that applies not just to climate, but to our democracy, all of the challenges that we face. the bad actors that we're talking about, who have targeted climate action, but really that's just a part of a larger targeting of democratic governance. And there's a parallel session going on right now that I would love to be in about the threats to democracy. That is the larger threat that we face today. Because there is no path forward on climate or any of the major challenges that we face that doesn't go through sort of a functioning American and global democracy. So again, one of the tactics we're seeing is this idea that it's too late to do anything. And by the way, if we do act, there are alternatives like geoengineering. We can just continue to burn fossil fuels, but we'll do other things to the planet. We'll put particles into the stratosphere to reflect sunlight. We'll engage in an unprecedented planetary effort to manipulate a system that we do not understand perfectly. And the principle of precaution reigns supreme. And so we have to be aware of where the battle is today. It's not so much about science denial, and the obstacles aren't physical. We have, the latest science tells us it's not too late to stabilize warming below truly, devastating levels of planetary warming. It's not the obstacles aren't physical, they're not technological. We have the technology to decarbonize our world. The obstacles, at least today, remain political, and political obstacles can be overcome. And I think we saw a profound example of that just within the past few days, that when people rise up, when people use their voices and their vote, it is possible for positive change. And so I'll leave it there.
All right, well, thank you, Michael, and thank you, Lisa, for those introductions. I'm a geoscientist, so I was trained and I still look to the past for guidance to the future. So again, I like to tell stories, as we know from this morning's panel when we were chatting. So let me tell you a story about using the past to look to the future. And we're going to go back actually to the late 1940s. And the US military, a really respected institution in this country then and still now, was worried because the ice in Alaska and the ice in Greenland and the ice in Canada was melting. And they said, the climate's getting warm, what's happening, what do we do? How are we gonna be able to repulse the Soviet threats coming over the top if the snow is melting? And what do? They got into understanding climate and climate change. This is in the 1950s. So if anybody asks you who in the United States first studied climate change, it was the US military. And it was strategic, it wasn't political at that point. Their study of climate change, the sort of epicenter of it was at a place called Camp Century, which I have had the privilege of studying and learning about for the last 7 years now. Military base, 200 people, I should say men because there are no documented visits by a woman to Camp Century. It was a camp built into the Greenland ice sheet. So these people lived inside the ice sheet. They were supported by a nuclear reactor. Think about that, 1960, a portable nuclear reactor gave them their hot water, gave them their power, gave them the ability to do science inside an ice sheet. That is American ingenuity. And that, I will say to Michael, is the idea that we have the technology to solve a problem. We don't have the will to do it. But in 1960, the Army had the will. They didn't want to drag diesel across the ice because it was too expensive to do it. And it would have been 75 or 80% of their entire logistics budget just to bring the fuel in, so they built a nuclear reactor. That camp left us with a legacy. The camp is long gone, it's buried in the ice. We could talk about the waste and everything there, but it left us with a legacy which is the first deep ice core that was ever drilled. That ice core was investigated up and down and back and forth, and we learned about the last 100,000 years of climate. And we learned, if you take the hockey stick on one end and the Camp Century core on the other and put them together, we learned about natural variability, and we learned about what we are doing today as being completely outside the range of nature's variability of change. Climate changes all the time. It's a perfect denialist trope to say, hey, it's changing now, it changed before. We know how it changed before, and it changed at nowhere near the rate it's changing now. So that's the difference. That ice core was analyzed, but they left about 11.5 feet of sediment at the bottom because they had no clue what to do with it. It was frozen. It was Greenland underneath the ice, right? And our lab was really privileged to lead a study that's gone on now for 5 years of what that sediment told us. And what it told us is that the ice sheet has melted before. It was about 400,000 years ago, and you guys are like, 400,000 years ago? God, my mortgage goes 30 years. How do I compare all this? But 400,000 years ago was a warm period. It was a warm period about as warm as we are right now post-industrial. Except there was a huge difference. There were 285 parts per million carbon dioxide in the atmosphere 400,000 years ago. Anybody know how much is in the atmosphere today? Yeah. 25 or 26 or 27. We are half again higher than the last time the Greenland ice sheet melted, or at least a large portion of it did. And that should be frightening, right? Nature melted the ice sheet with a lot less carbon dioxide. We've put a lot more in the atmosphere. We've increased that radiative forcing that melts ice. And so we know this now, right? We come in knowing this, that we have a fragile Greenland ice sheet. And if the ice sheet completely melts, 24 feet of sea level, 500 million people are going to lose their homes and their places to live, right? And their businesses and the ports and all that's going to disappear. Trillions, tens of trillions of dollars of economic losses. That's depressing and that's worrisome. But what I want to say to this is that the people who built this base, who designed the technology to drill through the ice, were driven by opportunity, by whimsy, by wonder, by ingenuity. And my takeaway from this is not that it's the end of the world, it's the doomsday, but rather that humans are really ingenious. And if they could figure out in the 60s how to drill through an ice sheet, how to live in a glacier, how to go to the moon, we can damn well figure out how to decarbonize our economy. And again, echoing what Michael said, we have the technology to do it, we need to have the will. And he would suggest it's political. I would suggest it's maybe the same thing in a different world, that it's social, that we somehow have to find a way to get people as a group to socially agree that this is the right thing to do and it's the thing we need to do right now. And I guess that does translate into politics, but it'll be fun to talk about this. So that's my story.
Well, I'm so glad I chose this chair to sit in, because what I would like to talk about is like a perfect segue into these three. I really love thinking about efforts to address climate change as sort of a tapestry of interconnections. Threads from scientists who sort of document our risk, like Lisa, and understand those risks. Strands from technologists who design ways to sort of move us from the disasters that might happen. And filaments of policy makers who make the laws and regulations that might contain the negative effects of climate change. But I would like to focus on another element, and that is how we bring people in to this understanding and actions about climate change that are outside of science, outside of technology, and outside of policy. And I'll give you a little background on that. I'm a forest ecologist, as I said, who studies forest canopy organisms. I work in Monteverde, Costa Rica. How many people have been to Costa Rica or Monteverde? Great. So you had been acquainted with the complexity and the beauty of those tropical montane forests. Well, the cloud forest canopy is very poorly known, but we know now that it is critically important because these diverse canopy plant communities that live in the treetops have evolved to absorb and retain nutrients and water from mist and cloud that passes through them, inputs that come from outside the ecosystem. But we're deeply concerned about climate change and how it affects these systems and the people that depend on them. And that concern has led me into public engagement. And actually, I'm really terrible at talking to policymakers, so Mike, I'm kind of envious of your ability to do that. And so I have shifted towards speaking to the general public, especially to those without access to traditional science education outlets, by engaging them where they live, where they work, where they gather, where they worship. And what I'd like to do in my few minutes here is to share a case study, so to speak, of from Monteverde, Costa Rica, where I've carried out research for 4 decades, as kind of a world in miniature to examine this tapestry of interactions between science, public understanding, and climate change. So for the past 8 years, I've been working with a team with support from the National Science Foundation who have been studying the effects of climate change on these canopy plant communities that live in the treetops. And these communities are very sensitive to climate change. because of the what we call the fog lifting effect of higher land and seawater temperatures, where clouds are forming higher and higher up the mountain as we warm. And sometimes they actually blow over the mountains altogether. So that cuts off the source of water and nutrients upon which these canopy plants survive, and that in turn disrupts the forest ecological cycles of the forest as a whole. And that actually has made us predict that by 2030, these canopy dwelling plants will be in decline or disappear altogether. So to explore this, our team carried out an innovative experiment where we removed all of the canopy plants from a set of experimental trees, and we compared the microclimate and the water use of the host trees between these strip trees and with intact trees. And what we found was that these strip trees experienced significantly drier conditions within the tree crowns, and their host trees experienced more water stress. So the key here in terms of what we're trying to do now is to share these findings about the effects of climate change. Well, we certainly do that through our scientific publications to other scientists, but we've also created 6 pathways or 6 threads by which we're trying to weave the local and regional human populations into this research. So, for example, we recruited local landowners to host our research, and we've installed bilingual signs to let the ecotourists who visit their farms and their hotels that they support climate research. Secondly, we've relocated those canopy plants that we stripped off and threw to the ground in our stripping experiments into a greenhouse, and we bring natural history guides and school groups and ecotourists to take a look at these canopy plants close up and use them as metaphors for water conservation in their communities. We've partnered with regional zipline companies and installations so that the hundreds of thousands of people who go to these zipline operations can learn about the canopy plants that zip by them as they go through their thrill seeking. We run community science lectures, we've produced a podcast, and we give talks at elementary schools with forest-themed coloring books so that elementary school kids can learn about this element that's being threatened by climate change. In 2023, we started the Monteverde Conservation Film Festival, where we've reached 300 people with these short documentary environmental films and many more through schoolyard screenings. We also, and perhaps in terms of action, collaborate with a local climate action group called Cor Clima. They work to reduce emissions, to expand EV infrastructure, and to mobilize community efforts. And so through monitoring and action, this group becomes a part of both the science and the solution. So, these 6 strands, when I lie awake at night and think, what can I do about climate change? In many ways, I sort of feel happy about these things we've been able to create. But I also have to say that some nights when I think about that, I feel like our efforts have been so small. Like, this is a small community. These are small actions. But I think, and I'm going to echo Lisa in this in terms of trying to be optimistic, is that small local actions, I think, can have impact if we invest in communication about science, and climate action through the channels that people already use. And I'll just say one other thing that in terms of small actions, I did this math where I learned that there are 350 million people in our country. There's 6.2 million scientists and engineers. And so if you do the division, you realize that if each scientist and engineer, and how many scientists are there here in this audience? I know there are a ton of us here in Boulder. Talk to just 52 people a year. That's 1 person a week. Then we will have reached every single person in our country. So if you talk to your barista about shade-grown coffee, or if you talk to your Uber driver about EV and about how the cost of solar power is going down and batteries are costing less, I think that can be one pathway to effective climate action. So I think the complex tapestry of climate change efforts to move us forward is not just about innovation in science and innovation in technology and pressure in political realms. It's also about an innovation in connections. Thanks.
Thank you all for these really wonderful perspectives. I think in trying to weave a question around addressing some of the uncertainties in sort of path forward, we've talked about, sort of the innovation related to decarbonization and renewables, some of the issues related to our understanding of the climate system, but yet in the technology available to us. And we've talked about how the variability over time has been quite huge, and we're only now kind of unpacking that and thinking about sort of the natural networks that Nalini was talking about, and then the local actions. Given all that, and thinking about some of the uncertainties in this transition period of the climate system itself and the extreme events that we're experiencing, then both in looking at our understanding of the climate dynamic and where are the surprises given these uncertainties and sort of the ocean, land, atmosphere interactions, which are so changing dramatically, especially with the Arctic Ocean changing its influence on the Northern Hemisphere climate. And then looking at sort of the other end of the loss and uncertainty about local knowledge, and how do we actually maintain that and utilize that in advancing technological advances. I think to me are a couple of threads of looking at extreme events as we look at both understanding and implementing innovation, technological innovation, and also the social dimension in how we capture that in a way that is effective. So,
You want to just go in order?
yeah, or whoever wants to go first.
Yeah, thanks Dennis for that. Thanks, Dennis, for that great setup question there on uncertainty. What's amazing to me, and I agree with Michael that that scientists are not actually fighting about the science anymore of climate change. We know a lot about the science of climate change, and yet.
I disagree with that, actually.
Well, that's what I was going to say, and yet there's a lot of surprises that are coming to light, and one of them that just was written about recently are things like the albedo of the planet is changing, meaning how reflective the planet has been changing over the last 20 years. And we could expect some of that. We think, well, okay, if the ice is melting and ice is really reflective, that makes sense, But the fact is, we actually can't attribute right now why this is happening, and it's different in the northern hemisphere and the southern hemisphere. This is a big mystery, and it's basically to your point, Dennis, that this is there's stuff we don't know still about how the climate is changing, how our actions are changing it, or just how natural variability is playing in to the forcing that we are delivering through additional greenhouse gases. So to me, it's surprising, and it just points, I think, to the humility we need to be modeling, be inhabiting as we think about what the planet is doing, how we're going to be living on it, how we're going to be adapting to the changes that are coming, and the fact that we are not always, our models are good, but they're always wrong, as the modelers say, So we need to be really humble about what we think we know, and always be questioning, and always be trying to understand, and still observing the Earth, observing the planet, so that we actually can track better what is happening as we're especially going into this unprecedented time.
Yeah, and I was just kidding. I do agree with Lisa. And again, it's a perfect segue. One of the things that I like to address, and again, it gets at this issue of doomism. There has been, there have been a lot of headlines, clickbait, sort of news articles that make it sound like the climate is spinning out of control. And if it's spinning out of control, well, then it's too late to do anything about it. And as I like to say, the great Steve Schneider, who was here at NCAR decades ago, and he was a good friend and a mentor of mine, and he used to say, the truth is bad enough. The truth is bad enough. And the truth is that the planet is warming up pretty much steadily as we expect it to, as we continue to put carbon pollution into the atmosphere. We actually have an article, maybe I'm making news here, we have an article that's embargoed, it'll be coming out within a couple weeks, that basically shows that the 2024 peak in global temperature, this anomalous peak, actually is consistent with what the models predict, the steady warming as we pollute the atmosphere with carbon, plus the effect of a substantial El Nino event. And so actually what has happened over the last several years is consistent with the climate models. Those same climate models tell us that if we continue to burn fossil fuels and put carbon pollution into the atmosphere, the planet will continue to warm up, and it won't stop doing that until we bring carbon emissions to zero. So the truth is bad enough. The truth tells us that there is great urgency, but it also tells us that there is agency, and this is part of my messaging. One thing I'll add here, how many people in this audience endured the 2013 Boulder floods? Okay, yes. And the March heat wave out west. So both of those events are examples of events that are not well captured by our climate models. Some of our current work is looking at how the pattern of the way the planet is warming up is changing the behavior of the northern hemisphere jet stream. And it's changing it in such a way that you get these stuck weather patterns in the warm half of the year, in the sort of from spring through fall. The jet stream will often get sort of stuck in a pattern where there are large, low pressure systems that stay in place for weeks on end, and that's when you see the worst flooding. That's when you see the worst heat and drought and wildfires. And the climate models, here's the dirty secret, the climate models are not capturing that effect. They're not able to capture this phenomenon that's known as quasi-resonant amplification. In fact, the math that's necessary to sort of solve the wave equations that emerge in this problem are actually the same equations I solved when I was a physicist studying physics back at UC Berkeley in the 1980s. Some of the math that was developed to solve problems in quantum mechanics actually is relevant to understanding this way that the atmosphere is changing. And the models are run at a resolution that they're not able to capture that. Why am I going through all this? What it means is that even though the models are capturing the overall warming of the planet quite well, there are processes that they're underestimating, and some of these have deep implications. Ice sheet melt and collapse, and the potential for sea level rise is an example. These extreme weather events, the climate models aren't capturing the full impact that climate change is having on these extreme weather events. And so if anything, we're underestimating the impact that climate change is having, but the science does tell us that all of this pretty much stops. The surface warming and all of these impacts of that warming stops when we bring our carbon emissions to zero. So again, the obstacles aren't physical. They are not technological. They are political, I would argue. Sociological, political, powerful vested interests who don't want us to change our current way of doing things, that want to keep us addicted to fossil fuels, and we do need systemic change. We do need to vote and turn out and participate in collective action to put pressure on policymakers and those in a position to affect the policy changes that are necessary for us to decarbonize our societal infrastructure.
All right, I'm going to make some good trouble here in two ways. And I'm going to disagree with Mike on the impact stopping when we stop the carbon.
The surface warming. The surface warming stops. That's the best science tells us. The surface warming comes to zero very quickly after carbon emissions reach zero. That is the state of the science.
But the impacts don't stop.
Not all of them. Yeah.
Because there's a lot of inertia in this system that we're dealing with. And so the ice will continue to melt, the sea level will continue to rise. So I think we have to be really cognizant of that we can say, oh, we got net zero, right? But we haven't solved the problem. We still have an atmosphere with a whole lot more carbon dioxide than it had and a whole lot more radiative forcing than it had before we got there.
Well, okay, so just so the CO2 actually starts coming down. The reason that global temperatures, that we don't see continued warming for decades after carbon emissions reach zero, what we call committed warming, what the models used to predict, is that using more elaborate climate system models today, we understand the role of the carbon cycle. It's pulling CO2 out of the atmosphere. So the CO2 is coming down. There's the inertia effect. There's the negative CO2 inertia effect. The two basically cancel out. So the CO2 actually starts to come down. That offsets what we would otherwise otherwise see as committed future warming. But the subsurface warming continues on. The ice melt, the ice sheet collapse, those things do continue on, as you say.
Right. So the second piece of my provocation here will be, when do we know enough to stop doing the science and really focus on taking action as scientists? And I would argue, in my personal view on this, the last decade I have gone from, I need to get more of these data, to, damn it, I got to do something about this in my years left on the planet, right? And so I think this is
no disagreement about that.
No, but this is the question of, as scientists, and especially looking at the current science funding, the policy, the way this government is working, it's striking me more and more that we need to think about where, when, and how we're going to take action, and what is the science we really need, right? I mean, we as scientists are really good at posing the next cool, fundable problem for our proposal, but guess what? The system is completely disrupted right now. I can't go ahead and propose the next incremental piece of science I want to do because it won't get funded anymore from what I have done in the past. So I need to start thinking differently, and that thinking differently for me in the last 5 years has been science communication, not to other scientists, but to the public. And it goes after your calculations, which got me thinking another way about this, that I could influence thousands of people a year by doing things like this, but how many of those people am I actually changing their minds about? Because I am mostly speaking to people who think generally like I do, not exactly like I do, but on sort of my side of the political spectrum. And that's challenged me to think about, how do I get out of the essential climate echo chamber that I've been in? And that might be the people who read my books, that might be the people who read my opinion pieces, and it's a real challenge. And so I'd like to toss that out there of, how do we go from the incremental science that we are mostly doing to action on climate change?
Yeesh.
You're at the end of the table.
No,
Come
I'm
on.
at the end of the table. I wish I were up there. No, I think all of these points, I think, lead me to think about responses to what's going on with climate change. And so I'd like to just kind of put a bigger picture on it, which is thinking about systems. And I think whenever we think about systems, we think about some sort of stable thing, the planet Earth up there, the new images of Earth from the other side of the moon. We're just like, wow, this is a system that's just a beautiful, stable thing. But all systems are subject to disturbance. In your personal lives, in my personal lives, we experience disturbance. We might be in a car accident. We might experience a disease that hits us. We might win the lottery. That's another disturbance. We all experience COVID as a disturbance in our stable system. And in fact, the definition of disturbance is the interruption of a settled, known, and stable condition, an interference with what we expect. And so climate change, when you look at the long term, or in the not so long term, is a disturbance in what we have been experiencing and measuring over long periods of time. And so I'd like to just sort of bring in some thinking that I got from an interdisciplinary colloquium that I started about disturbance and recovery, and how systems emerge from that. I study disturbance in ecological systems. One of the things I'm really interested in is forest fragmentation, and what happens to trees and forest canopy organisms when they get isolated in pastures, when the trees around them are all cut down. How do pollinators get to them, or fruit dispersers? And I tried to get an NSF grant to study this, but I was turned down because there's no real ecological theory that would allow me to generalize beyond my own particular study site. So I thought, well, a clear cut in many ways is like a burn patch of a skin in a landscape of healthy skin. So a clear cut in a landscape of healthy forest. Maybe somebody in burn trauma can have some theory that would help me understand relic trees and theorize about that. So I called together an interdisciplinary colloquium of faculty who study disturbance and recovery in their own fields, which included a traffic engineer, a modern dancer, human development person, a refugee studies person, a macroeconomics person, a burn trauma person, and a neuroscientist. And we met for once a month for a whole year, a school year, and we put our heads together. We first spent, each of us had a time to talk about how we in our own discipline handle and understand disturbance and recovery. And then the second semester, we talked about emerging precepts that came out of this, because the whole idea was to see whether we could exchange theories, tools, and approaches that would be helpful to our own fields. Well, about 9 precepts emerged from that, boiled up from that, and I'll share 3 of them with you that I think are relevant to our discussion. One was that in order to respond to disturbances, you should seek knowledge from diverse sources. So when I was studying these relic trees, I was going to the literature and reading, from Dan Jansen and other ecologists, Karen Hall, what happens with relic trees when you isolate them. But I never talked to the farmers who actually leave the trees in the pastures, or the women who collect medicinal plants around those trees. So I began seeking information from diverse sources. The second precept was to enhance the web of relationships. So that concern, that disturbance. And so our researcher in refugee studies talked about the Karen immigrants from Burma and then Thailand who came to the United States, and they maintained their cultural ties even as they're being assimilated into our culture by carrying out ceremonial dances, the wrist tying ceremony and so forth, and that maintained or helped to maintain their cultural identity. The third precept that emerged from that was that in almost every one of our disciplines, we realized that although we think of disturbance as starting from an original state, a disturbance happens, and success is returning back to that state, what we realized was that that almost never happens. You arrive at what we called a third state, neither the original state nor the disturbed state, but some other state, some novel state that happens. And so when I think about all of us weaving together this tapestry of climate understanding and climate action, I think about those three precepts. And I actually think that we're doing that here in our Conference from World Affairs and the activities that all of us are involved with, which is that we are seeking knowledge from diverse sources. We are enhancing our web of relationships by these conversations together. And I think we are trying to anticipate what that third state might be. And it may well be, Lisa, an optimistic third state that you're talking about that would not have happened if this disturbance had not happened. And so that's, I think, what I can bring in terms of thinking about the larger sense of disturbance and recovery and emergence into that third state.
So before I get into a very deep question about technology, would you have some comments to reflect on what you all said to each other and just kind of share, a reflective comment across, the four of you?
I'll just say really quickly, I think it's interesting that all of us, we're on a climate science panel. All of us, though, are talking about what we can do outside of science. I mean, I literally quit my professor job and went to an NGO where I felt like I could take climate action. And yet what I discovered being at the NGO is, I mean, my job is science at the NGO. There's still a lot of need for science. But like Paul said, it might be like a different kind of science. It's like trying to figure out what science is actually necessary. And for me, it's thinking about the solutions that people are proposing, or the options. Let's not even call them solutions, the responses. Or thinking about understanding, well, what's happening right now in the climate that actually changes the way we adapt or the way we build our power systems. Or if we're trying to be resilient with our electricity system, for example, what kind of science do we need to support that? So I think that there's an evolution actually, but we still really need science. And by science, I mean the inquiry, that disciplined process of inquiry where we just don't follow our assumptions in our head. We actually test stuff out. All of us are kind of scientists, actually. We all kind of want, well, hopefully, we're kind of testing out. We have an idea, we go and we test it out, see if it's true or not, by collecting data or information. And I think that I just wanted to say that in response to Paul a little bit, because I do agree that things are changing, and I just want to say also on the science situation, it is really dire out there right now. Everywhere I've worked in my career in climate science is under attack, and funding is being taken away. And I am at the more senior in my career, but there are young people out there who are looking at a vast emptiness of where can they go for their career. So that's the people I'm really thinking about as this science situation is evolving, and I hope that we can bring the optimism and new science that we need to be doing, or at least new ways of using the technical training that they have to bring all that energy and spirit into our, again, our long marathon that we're on right now, because it is really, really serious for the next generation of scientists. Thank you.
Thanks. Yeah, and I'll sort of also echo this point that others have made, the importance of scientists engaging with the public and with policymakers. more than a decade ago, back in 2014, I published an op-ed in the New York Times, the title of which was "If You See Something, Say Something." And it's about our responsibility as scientists to report what we're seeing and what the implications of that are. And we shouldn't have to apologize for that if our science and our understanding of that science informs our assessment of risk and our assessment of the importance of communicating that risk to the public. We should not have to apologize for that. And so I think that scientists do play a critical role in informing that larger conversation. That doesn't mean every scientist should be out there speaking to the media and giving public lectures. We know scientists who are probably best left in their laboratories doing the important science that they're doing. But for those, especially young scientists who have a passion and a proclivity, we've got to provide opportunities for them to engage, and especially in this challenging media environment that we find ourselves in today. I just came from Cambridge, UK, the Cambridge Disinformation Summit, and let me just tell you, it was a sobering experience because we are, there is a fundamental challenge to our informational ecosystem, and if we can't solve that problem, it's going to be very difficult to solve any of these other problems. I do want to say something about, here, in Boulder, in fact, I think if you look in the right angle, you can probably see the Mesa lab. I didn't check yet. I think you can see so many of you probably know that story. It is being defunded. This is one of the great institutions in our field. So much critical early climate modeling work was done there. And I wrote a commentary in the Bulletin of the Atomic Scientists about Project 2025 back in August 2024 and the threat if Donald Trump was reelected, we would see the implementation of Project 2025, and we're seeing it in a profound way. And one of the primary goals of Project 2025 is to destroy our infrastructure, our clean energy infrastructure, and double down in fossil fuel dependence. And the fossil fuel industry played a really important part. I want to read the architect of Project 2025, Russell Vought. Some of you probably know that name. In a tweet called the Colorado Center, the National Center for Atmospheric Research, one of the largest sources of climate alarmism in the country. And so you've probably heard reports that it was the governor. This was an action by the Trump administration to penalize the governor of Colorado because of some of the political actions he had been involved in. Don't believe that for a moment. This is central to their agenda. That's the reason they're going after NCAR. It's iconic. It's the reason they're going after the Mauna Loa Laboratory in Hawaii, where CO2 was first measured in the atmosphere. It's iconic. It's the reason they're going after the NASA Goddard Institute for Space Studies in New York City, founded the former director James Hansen, who was one of the early sort of leaders in the climate field. It's in the same building as the Seinfeld Diner. So it is iconic. And so they're going after these iconic climate institutions because they're going at the heart of the scientific community. They're trying to dispirit the scientific community, destroy the spirit of the scientific community. That's why it's so important for us to be here today, standing up to that.
So I could not agree more strongly with Lisa and Michael, and I think the critical piece in there are the young people, the early career scientists, because if we lose that connection generation to generation in this, then the destruction of institutions is really going to matter. If we can continue training the students who will become the people that we are now 30 years from now, then okay, they can take out the institutions, but it doesn't change the trajectory of climate change. And I think that's what's most striking to me is it doesn't matter whether you voted red or blue, independent, whatever. Climate change is going to affect you exactly the same way. It certainly matters that NCAR disappears, but does the climate system care? Not one bit, right? So these are performative actions. They're actions of angry people for whatever reasons we can discuss why they're doing them. But it's not going to change the trajectory of our climate. That's going to be changed by the carbon dioxide budget in the atmosphere and our land use changes that we do that are tied to that. So I think we, in some ways, we need to keep our eyes on the ball or our eyes on the prize or whatever, which is how, in what hopefully is either a 2 or 4 year period, depending on how the politics works on this, how do we keep the graduate education going? How do we keep the science that we're doing with less funding going? And how do we keep this energy that we have and not succumb to what I take as an attempt to really, I don't know how else to say it, but sort of neuter the climate science establishment. Yeah, sure. The climate science establishment, those of us who do this for a living and think about it for a living, if they can dispirit us so that we stop, then they win, right? But the climate keeps warming, and if we become the internal combustion engine capital of the world, well, that's where the United States is at, while the rest of the world is driving EVs and being more comfortable, like you say, and going faster and having no repair bills for mufflers and things like that. So I'm a hopeful person. I hope you get that. And I think that if we can keep our spirits up, this too will pass. And I really love your idea of a third state. When this is through, could we, in fact, having suffered this pain, be in a new place that might have been a better place than where we were before? And I guess that's what keeps me getting up in the morning and writing and thinking and doing science and training students.
Thanks, Paul. I just have a little bit to add to all of this wonderful stuff about this topic of science and the importance of doing science. And I think we have to keep in mind that not only are there external forces that are sort of threatening science right now, but the scientific process, the academic world itself, has put limitations on scientists, especially emerging scientists, graduate students and young assistant professors, where the academic system rewards scientists communicating with other scientists, which of course makes a whole lot of sense. It's our community, we can talk jargon with each other, we promote each other's work, we grab questions from other people's work in order to ask and answer the next question. But in the realm of academia, and I'll also say that historically, like for me, being so old, I've been in academia for 43 years now. When I started out as a young assistant professor at the University of California in Santa Barbara, I had a real sense that I wanted to do public engagement as well as hardcore research. And I was discouraged by my peers. And I would sneak out to talk to Girl Scouts, and I would sneak out to talk, to give public talks, because my peers would say, Nalini, you are wasting your time. You should be writing more proposals and publishing articles and peer-reviewed articles. Well, that trajectory has really changed, I think, over the last 40 years. There's a lot more understanding that scientists can be advocates, can be spokespeople for science in society. There are more trainings available now. There are more outlets for that. There's more rewards for that. But it's still considered something less than the intellectual merit activities that we as scientists are rewarded to do. So I think one of the things that we as scientists can work on is applauding, supporting, giving kudos to those scientists, and it is a subset of scientists who might want to or are capable of doing this, but that we can shift the academic system itself so that we can become better members of this tapestry of people who are trying to understand and promote actions that will mitigate the negative effects of climate change.
Can I say one more thing?
Sure.
Well, you can applaud. Go ahead. Again, how many of you in this room are scientists? All right. We need the rest of you to help with this. And I just was sitting here listening to you talk about that. You have opinions, right? And you can voice those opinions, whether you voice them to your friends, whether you write a letter to the editor, whether it's in the way that you vote. You can support the science and the rational thought that'll help us move forward in this world. And in fact, this is a plea to all of you that we need that. We need your voices supporting science and supporting a better climate future, be it through decarbonization, efficiency, all those different things. If you walk out of here and write a 200-word letter to the editor, that's kind of job done, right? That's starting the process of being socially, or as Michael would say, politically active and getting your voice out there. And to the younger people in here, what I've learned from mentoring now probably 2 generations of students is editors at newspapers listen to you, right? They like having op-eds not from people my age or letters to the editor, but if you're in high school, if you're in college and you write, you have a particular power that some of us who are older do not.
Mm-hmm.
Or Paul, make a TikTok video. I think we're a little bit op-ed letter to the editor. This is, there's other ways that like younger people communicate
You are
these days.
absolutely right.
Well, yeah, I was just going to say, yeah, I agree with all this. I think that we have to use our voice, not just our vote, but our voice, and there's so many ways to do that. And sometimes we have to get outside of our comfort zones and engage in some of these social media platforms that maybe we haven't used before, because the conversation is moving. It's moving from the traditional media into sort of the new media of the new online media and podcasts, and there are that's where a lot of people are getting their information. And if we don't engage in those spaces, we're leaving them wide open. That's one of the things that we saw in this last election, that a lot of those, especially the sort of the manosphere podcasts, where so many voters were influenced by this space that we weren't even in. And so we have to recognize the new opportunities, and of course, engaging young folks, because they know, they're comfortable with those platforms, getting them involved as well. That's so critical.
So we have about 10 minutes left for the discussion here. And there are several questions kind of aimed around technology and geoengineering. And I'm going to rephrase the initial question about, thinking about how we think about geoengineering, in the sense that fossil fuel use is a geoengineering experiment that really promoted and brought on the Industrial Revolution. Land use change is a geoengineering over centuries that structured the whole landscape, but the biosphere, the ecosystems that we depend upon. So as we think of the perverse consequences of those acts, which served society in a very fundamental way, as people think about geoengineering today to solve the climate change question, how do we actually think about it in a way that reduces the unintended consequences, that people, and especially engineers and politicians, don't think of the Earth system as a system, and so that they think of the silver bullet, which then maybe kills the biosphere in the ocean. That really kills, sort of some of the dynamics, or causes feedback processes in a way that's difficult to turn back, to control. And so let's think about your thoughts about geoengineering. How, what are the benefits, and how should we think about utilizing our technology in a way that's feasible, safe, and sustainable?
Yes, and since I brought up geoengineering in the first place, let me be the first one to try to tackle that. So it's important for us to clarify the language, what we mean by that term. And so geoengineering generally, and certainly in the way I use it, is the intentional manipulation of the Earth system to address, for example, human-caused warming and climate change. Arguably, fossil fuel burning was an unintentional manipulation of our planetary atmosphere. We didn't set out to try to warm up the planet. It was a consequence of those actions. And now geoengineering, at least the types of geoengineering interventions that I'm talking about, are an effort to try to offset that, rather than address it at its source, which is the continued burning of fossil fuels. As I like to say, if you find yourself in a climate hole, stop digging and burning fossil fuels. And so one of the dangers is that we sort of give in to this idea that, we can just engage in these other manipulations, and that'll offset the effect of global warming. And I would remind you, how many of you folks grew up with that song, "There Was an Old Lady Who Swallowed a Fly"? Okay, and it wasn't the fly that killed her. It wasn't the frog that killed her. It was the horse, of course, right? It was the geoengineering solution to that problem that began with the fly. And so, to me, it's sort of it's a metaphor for the fraught path that we go down if we try to address this problem through some other means rather than attacking it at its source.
I'll just for the audience, and to kind of present like some of the thinking about this too. Agree with Michael on the let's take this apart a little bit. So there's geoengineering. There's two kind of big buckets of this stuff. One is carbon dioxide removal. People use that term, and what that means is trying to suck carbon dioxide out of the atmosphere. So trees do that normally, and there's quite a lot of effort now to reforest, for example. That could be called carbon dioxide removal. But there's other engineered solutions like direct air capture, which would be like a giant fan kind of sucking in the air and then taking the CO2 out of it and then burying it under the ground. I mean, the key with these things with carbon dioxide removal is you got to get the carbon out of the atmosphere and bury it, or get it away from being able to come back again to haunt you. Second group of things is solar geoengineering. I think that's probably what you're mostly talking about, is, the idea is trying to reflect more of the sunlight coming into the earth. So to directly, change the heat balance of the planet. Now, as Michael said, that doesn't do anything for greenhouse gases, right? It's like a mask on top of these greenhouse gases building underneath. So rightly, there's a reason for concern there, because it is not actually directly addressing the problem of greenhouse gases. That said, the people who research this topic, all of them write in their papers from the start, this is not a substitute for greenhouse gas, emissions reduction. Responsible scientists that are researching this know that it's not a substitute. Will there be, though, a moral hazard where, some other actor in society wants to make that argument that Michael was representing? We don't know. But I think that these kinds of, to the spirit of the question, people are investigating these technologies, both groups of technologies. The IPCC, which is our big kind of assessment every 5 years of the state of science, has said we might need carbon dioxide removal, just because there's so many difficult to decarbonize sectors, or not so many, but a small group of really stubborn kinds of things like heavy industry and aviation that are tough to decarbonize. So you might need this carbon dioxide removal function. It does not really exist at scale right now, though, at all. The other thing, solar geoengineering, doesn't exist. It's in modeling, it's in research papers. It's been talked about for quite a long time. But there is this idea, which Michael said well with the idea of the fly, of unintended consequences. I think research is needed, because if people might choose to use this that are not in our country, it might be some other country. People might decide they want to use it. People might say we don't want to use it. But research actually gains knowledge about it. So that's one way to look at it, is there a role for science to gain knowledge about these as activities? That said, this is not just a scientific issue, whether we would ever use something like this. This becomes an ethical issue. It becomes a governance issue. Who makes the decision to launch, especially the solar geoengineering type of technology? So anyway, that's like my little nutshell. These are really being discussed, but again, they're sort of in their infancy in terms of whether they're playing a big role right now in the climate solution space, I would say.
Just very quick, I agree with everything that Lisa just said. There's some nuance here, and sometimes it's hard to unfold all of that in a short amount of time. But the moral hazard is probably the fundamental issue here, because it applies to any of these schemes. And the moral hazard is, if we think we've got some stopgap solution and it's going to be cheap, it becomes a crutch for those arguing that we don't need to decarbonize. And we've seen that. We've seen some bad actors. We've seen fossil fuel front groups. The CEO of ExxonMobil said, for the first CEO at ExxonMobil to say, Rex Tillerson, to agree that climate change was real and human caused, said, but it's a technical problem. There's a technical, and he appeared to be arguing that the way out is geoengineering. The carbon capture isn't 100% perfect, and so there's some really good work by people like Mark Jacobson of Stanford who have shown that actually, you still need fossil fuel energy to run the equipment that's capturing the carbon. It's not 100% efficient, and in fact, some of the captured carbon is being used for enhanced oil recovery. And so if you actually drill down and you do a full cost accounting, it's not carbon neutral, and renewable energy is carbon neutral. And so they're not on the same footing. So it is a complicated issue. And like Lisa said, fundamentally in the end, it's an ethical issue.
So we have 2 minutes before I reserve 2 minutes for myself. So 1 minute each.
I'll try to be quick. I want to come back to where I started, which is as a geoscientist, which is really a historian. And so when I was working on the book about Camp Century and Greenland's ice disappearing, I went down some rabbit holes about technology and unintended consequences. In fact, the piece I had the most fun writing was about those rabbit holes and failed technologies. And I look at geoengineering and it scares me because we think we know what we're doing with engineering. And my best example is nuclear power, too cheap to meter. That was also going to bring us the nuclear airplane and Project Plowshare and canals blown through by nuclear weapons and shale oil liquefied by nuclear weapons. We have great imagination, but we don't usually look at the downsides. And I'd say if we look at history, there are a lot of downsides to engineered solutions.
I'm looking forward to hearing Dennis's remarks.
Be afraid of Ice 9. So these are fantastic. It's really difficult to summarize everything and to address all the wonderful questions. I mean, there are questions related to where are the social actions and how do religious groups be part of this conversation. I think there are some of what I've heard today, there are mechanisms and roles for these different social institutions to be part of the voice, to really change the values and how we perceive these things. Very, very articulated in the panel today. A number of the questions we're addressing serve, the harmful health issues. How do we consider the public health concerns as well? And I think, again, you've touched on a number of things, but what resonates with me in what you were saying is sort of the interconnectedness of nature and how we look at the climate, dynamics and how we actually need to think about these as systems, including social systems and human activities and values. That the importance of public will and political will in changing the mindset of decision makers and I was going to put these in your word, interpret this as part of what you're saying, at multiple levels of governance, not just at the international level or at the federal level, but looking at ways communities can really be part of that governance and policy change. And lastly, there was a question here about the destruction of the science infrastructure, and I think a number of your comments of looking at early career, supporting science at all levels, but then really supporting early career scientists and that continuity of knowledge. And I would go beyond just sort of scientific knowledge, but also I think getting to some of the points that Nalini was talking about local communities, the local knowledge, and bringing that together so that the knowledge sharing across the whole dynamic of the Earth system is really critical, and respecting what the elders have. I'm an elder now, so I could say that, as well as hearing from the youth and hearing about their challenges, and so really listening as well as being part of a panel where we're talking heads, but being in the community and listening to what people need, what the Earth needs. And I think these are kind of themes that I kind of come to my mind in listening to you all. So thank you very much.
Thank you.
Thank you. One minute over, so it's okay.